All last week, the DIY community has been discussing the big new releases shown at Formnext 2025, and two of them really caught everyone's attention. I'm talking, of course, about the strange creature called Vortec from Bambu and the impressive collaboration from Prusa Research and Bondtech. Both of these devices represent a new type of toolchanger systems, where the printer doesn't swap the whole extruder but only the most important part, the hot end. But by the time they came out, I wasn't very excited anymore, because a couple of weeks earlier I had already built my own Hotend-Changer, super simple and super cheap, made of sheet and sticks, the way I usually build my projects. But let's go step by step. Hi everyone! If you've been subscribed to my channel for a while, you know that about half a year ago I made a cheap DIY AMS from parts I found at home. I called it Medusa MMU, and it even worked. Well, kind of. Even though the basic idea of loading and unloading filament through a single nozzle sounds simple, making such a system truly stable requires a huge number of extra components. A filament cutting knife, a waste collection system, a filament buffer, and many other small things that are absolutely required if you want the system to work reliably from print to print. And on top of that, this type of system has many limitations. It's slow and it produces a lot of waste. On the other hand, toolchanger projects and ready-made devices have existed for a long time. With the toolchanger, switching tools is much faster, just a few seconds, and you don't need to purge a lot of filament every time. But the complexity and cost of these devices scare most makers away, and scared me too several times. The community started discussing a new idea. Instead of replacing the whole printhead, replace only the essential part, the hot end with the filament, while keeping a single motor with the feeder on the hot end. It's not my idea, and it had been floating around for about half a year, since Bondtech announced their Hotend-Changing system INDX. But I got interested in this concept even earlier. A few months before that, I found a YouTube video from the Ultimate Toolchanger channel. In that video, the guy builds his own version of a similar one-extruder toolchanger. And as he says, the idea was suggested to him from someone from Bondtech, so I still have no idea what came first, the chicken or the egg. And as far as I understand, the project never became public. The channel hasn't uploaded anything in 10 months. And a couple of months after Bondtech, Bambu showed a teaser of their Vortex system, which they officially presented just a few days ago at Formnext 2025. I'll keep my thoughts to myself for now. It's a strange device. There is another interesting project on the Mihai Designs channel. It looks very cool, but to me it seems too complicated. So I decided to make my own Hotend-Changer. I hope no one I mentioned will get mad at me for this. And as usual, using whatever I had on hand, in just a couple of weeks I made this. Let me introduce you super budget Hotend-Changer MedusaHC. In this video I won't overload you with technical details. A detailed step-by-step guide will be released later, when I finish preparing all the models and make sure the device works stable enough. All models and source files will eventually be published in open access. For now, I'll just explain how, why, and what decisions led to this version of the device. As always, let me answer the most obvious comments right away. I fully understand that this system doesn't look reliable yet, and the repeatability still needs a lot of testing. That's what I'm working on right now. I also understand that many upgrades could be added: extruder boards, quick release connectors to avoid running wires, and lots of other improvements. I know all of this. But the whole idea of this project was to make the cheapest possible toolchanger using only simple and accessible parts and still get it to work. Yes, there are questionable parts, I agree, but this is just a very early alpha version. Everything may change many times. I didn't film much of the development process because when I'm in mad scientist mode, it's hard for me to switch between tasks, so not all of the footage will match exactly what I'm talking about. So I defined 4 main tasks that had to be solved for this project: opening and closing the feeder, attaching the hot ends to the toolhead, attaching the hot ends to the dock station, and the software part. The first task turned out to be the most interesting and the hardest. At first glance, it seems simple. Just press the feeder lever before installing the hot end and release it when the hot end is in place. But a few problems appear. The force needed to press the lever is quite high, because the filament must be held tightly, and you can't use a weak spring there. And making the XY motors apply that much force is dangerous. Sooner or later, one of them may skip steps, and then things can go very wrong. I don't see this method as reliable. The second option was to use a servo to push the lever, but because the force is high, the servo would need to be powerful, which means heavy. So that option doesn't work either. So I decided to try opening the feeder with the extruder motor itself. It's strong enough, and I wouldn't have to mount a heavy servo or push directly on the extruder. For the feeder I used a NEMA 14 motor and a Sherpa gear set. The gears are in the same position as in the Sherpa, but on top I added one more large gear from the same feeder on the spring-loaded lever. And on the back of that gear's shaft I placed an eccentric that opens the feeder. Because the gear is large and the pressure builds up smoothly through the eccentric, the extruder motor has enough power to open the feeder. Yes, the drive gears also move during this, and it will wiggle the filament a bit back and forth. But since the feeder loses pressure almost immediately after opening starts, nothing bad should happen. The first version was a bit bulky, but the concept worked. After a few tests and tweaks, I removed extra material from the feeder. I also changed the opening mechanism so that where the feeder opens, the lever with the gear locks in the pressed position. And closing the mechanism can be done with the quick move of the extruder motor. Now the downsides of this solution. First, in this version, printer doesn't know whether the feeder actually opened or not. I'm not ready to add a separate sensor for this yet. For now, the feeder is controlled only through software. The second big problem is that to open the feeder, you need to press the lever. Doing that at the same time as attaching the hot end is very difficult because all the movements are hard to sync in the right order. So I decided to separate the opening process from installing and removing the hot ends. On the left side I added a big ugly lever. When the tool head touches it, the feeder lever gets pressed and the opening mechanism starts. The force needed for that is very small, just a little spring from a pen. After that, the extruder can move away without closing, and when needed, a small move of the extruder motor can close it again. The mechanism seems to work, so I moved on to designing the removable hot end. About a month earlier, I switched my Duender from my custom extruder to a regular Dragon burner. Not because it was better, but because it was definitely more universal. So I decided not to reinvent the wheel and build my toolchanger based on the Dragon burner. Of course, I want to give huge thanks to the Warren project, the Dragon burner creators, and the whole DIY community that makes projects like this possible. I built my Dragon burner assembly in Fusion for the Bumblelab P1P hot end, merged some parts, split some others, and simply cut out the hot end with its mounts and fan from the extruder. Thankfully, the Dragon burner layout lets you put all of this forward very easily. Probably the most important part of the whole project is how the hot end attaches to the extruder. I had never made a quick release mechanism before, especially one where every tenth of a millimeter matters. And I was sure this would be the hardest part. But surprisingly, the very first version of the mount turned out so reliable that I never had to change it. The mount uses two M3 pins, a 12mm magnet, and several plastic guides that come from the Dragon burner design. Of course, I had to add small gaps everywhere so the parts moved smoothly but still fit tightly. There is a long upper extension on the hot end with the hole that holds the filament. In the center there is a cutout where the drive gears must land. In the first version I tried gluing two pieces of PTFE tube there, but PTFE doesn't like to stick to anything, even if you sand it well. In the end I made everything from plastic and it turned out reliable. The hot end part and the extruder both need to be sanded well in the areas where the parts will slide. All surfaces must be smooth and shouldn't create extra friction. It's a boring job, but the better you fit the parts together, the easier the tool change will work. You can also add a bit of thick grease to the friction points. Another very important part is the pins and the matching holes. The pins on the extruder, just like a magnet, are placed on the carriage mount that holds the rail. This way the main force during hot end removal goes almost straight into the center of the carriage. The holes for the pins are smaller than needed, and the pins are hammered in very tightly. A bit rough, but they definitely won't fall off. The main thing is to hammer them in straight and not bend them. This is very important. The holes on the hot end are more interesting. Putting pins in and out of raw plastic is not a good idea. The plastic will slowly get damaged. So I came out with this solution. At the entrance of each hole, I melted in M3 brass inserts and then drilled them out to 3.2 mm. This gave me a brass ring with no threads at the entrance of the hole. I also used a larger drill bit to make a small chamfer, so the pins slide in more smoothly. If you want, you can add the same brass rings on the other side, but it turned out not to be necessary. The models even have spaces for 2 more pins, but I never needed them. In the end, the hot ends slide in tightly all the way in, without much force, and lock inside with zero play. To attach the hot end to the base, I added 4 small 5 mm magnets in the front and 4 M3 screws that act as the hooks. So it was time to build the docking station. It turned out very simple. I just screwed a 2020 aluminum extrusion to the existing front mounts. First it was 2040, but even that turned out unnecessary. The main thing at this stage is to make the extrusion as straight as possible. It must be perfectly parallel to the extrusion the extruder travels on. The hot end mounts are made of just 2 parts. One piece in front that sets the X position and a plate with 4 locking holes and 4 small magnets. This plate can be adjusted in height and even tilted slightly if needed. The hot end locks onto the base in the plate's locking holes using 4 screws, and it's held and positioned by 4 small magnets. There is also a cutout in the plate so the hot end fan can pull in air while the hot end is sitting on the base. With that, the main mechanics were ready. I added another hot end, since my Manta M5P board has ports for it, added small metal plates that covers the hot end nozzles on the docking station, and the last thing left was the software part. At this point the system could be called dumb. The printer didn't know what was mounted, couldn't check where anything was, and couldn't verify if the tool change worked correctly. So making it work at this stage was easy, just a set of movement macros and the usual T macros for switching hot ends. And on the 7th day after starting this adventure, the system finally worked. By the way, those of you who already joined my Discord server can confirm how fast this project went from the first models to a working prototype. I post videos and updates about almost every step of my projects there. If you want to stay updated, join my Discord. There are many smart and friendly people there. And of course, if you have a possibility to support me, my projects and my channel, the links to Patreon and donations are in the description. This helps me grow and create more interesting things. So the toolchanger showed that it works almost right away. I had to tweak the opening eccentric a few times so it would always open the feeder wide enough and close back correctly. I had to add small gaps between some parts, basically just regular tuning work. I even managed to do a bit of printing. But one important task was still left, making the device at least a little smarter. I didn't even redesign any models. I just took a few old Ender-3 end stops, simply cut off the micro switches because I didn't need the board with the connector. Both on the extruder and on the docking plates there was enough space to place them. So I marked the holes, melted in small brass inserts and screwed in the switches. One switch on the extruder and triggers when a hot end is inside, and one switch on each base, which triggers when a hot end is sitting on that base. And then another fun adventure began, writing logic for the sensors and hot ends. Just like before, I'm still not a programmer, so I didn't use Python scripts, only the good old macros. I won't go into details now. If one day you want to know everything, I'll explain it. But here is what I managed to do so far. When the printer turns on, it can detect the current positions of the hot ends using the sensors. Before printing, the printer can automatically pick the correct hot end. If the wrong one is mounted, it will put it back and grab the right one. If something goes wrong before or after a tool change, for example if a hot end falls off, the system checks all sensors and pauses the printer if there is any problem. Pauses don't work perfectly yet. If you fix the issue and resume the printer stops the old macro and just continues printing with whatever tool is currently attached. You can manually pick the right tool with macro before continuing, but it doesn't always work correctly. I'll try to figure out how to handle pauses inside macros later. For now, the most important thing is that the printer can destroy itself. And here's another important improvement I made so far. You probably noticed that in the latest versions the printer no longer has the lever on the right side. I could have added a similar lever to every base and tried to sync all the movements, but I decided to solve the problem in a different way. Like I said earlier, using a servo to open the feeder wasn't possible because of its weight. But now I don't need to open the feeder itself. I only need to press the gear lever with a soft spring from the pen. And for that, even a simple cheap microservo should be enough. I didn't have one, and I couldn't find a suitable servo nearby. But my day was saved by Jonathan from the next layer. He had the right servo and kindly gave it to me. Actually, he gave me two, because I burned one like an idiot by connecting plus to minus. I quickly modeled a mount for the servo and made another eccentric for it, since it was already clear that this mechanism works well. I powered the servo through a step-down converter from the main power supply, because 5-volt line on the printer board isn't the best choice for the servo. Cheap servos can produce a lot of noise onto the power line. I updated the macros and now I freed the right side and was able to add one more hot end. And here I should explain a bit about connecting additional hot ends. Each tool needs a hot end heater port, a thermistor port and power for the fan. In my case I already had two full sets on the Manta M5P board, and I used one more port on the SKR 1.4 board, connected as a secondary MCU. The SKR also has two extruder ports, so in theory I can add a fourth hot end. Based on my calculations, this Duender can physically fit 4 hot ends. If I move or replace the BL Touch, maybe even 5, but that's unlikely. The extruder still needs some space on the sides to mount each hot end. With the third hot end, I found out that in some situations the old 350 watt Ender-3 power supply couldn't handle everything and Clipper crashed with an error. So I had to power SKR from a separate power supply, connecting the grounds of both supplies together. And finally I added a separate brush and small box for catching oozed filament for each hot end. Not everything ends up in the little boxes, but the brush with the rubber strip more or less does its job. This part still needs improvements, and I'm also working on optimizing the macros so everything runs smoother, faster and more stable. That's it, the main part is done. Time to sum everything up and think about the next steps. The system works now. Not perfectly, of course, but it works. Most issues at this stage come from the software side and the slicer settings. I still need to optimize parameters, movements, speeds, checks, pauses, and many small things. As for the printer's performance, after all these add-ons and the extra weight on the extruder, yes, there is a downgrade. After the first upgrade, the printer lost about 5K acceleration, dropping from 18K to around 13K, which isn't critical. But after adding a servo on top, the acceleration dropped to almost 10K and low-frequency resonances appeared, which is a bit disappointing. Right now I still print with a 10-12K acceleration, same as before, and I don't see any serious problems. I've already prepared lighter, redesigned parts for the extruder to compensate for the weight of the servo and its mount. But even at this stage, I must say, these results are much better than I was expected back when I was modeling the system. With a bit more tuning, I think I can get back around 5K acceleration, and that will be more than enough for me. By the way, at first I printed everything from ABS CF, and overall I liked it, but carbon fiber filament is not very good for parts that slide against each other. So I decided to experiment and printed the new parts with a smooth outer shell from pure ABS and infill from ABS CF for stiffness. My Duender loves ABS, everything printed very well, no strings, no oozing. Right now the Hotend-Changer process is pretty fast. A full change with all movements and short checks takes less than 10 seconds. This is close to a classic toolchanger. For comparison, Index swaps hotends in about 15–17 seconds because it hits them every time. Bondtech changed filament in about 40 seconds. It has to heat up, fit the filament, and also push out the cut piece. And AMS-style systems take over a minute for the filament change. Another 4–5 seconds are needed to print a perch tower. Yes, a tower is still needed even with the toolchanger. If you want clear print, you need to prepare the nozzle. The purge volume is set to 30 cubic millimeters, and there is no need for extra purging besides that. With my macros, the printer still produces a bit of oozed filament during hot-end changes, but this can be solved by optimizing movements, closing the nozzle correctly on the base, and placing the cleaning brush in the right spot. You can also use the ooze prevention feature in Orca. It lets you set how much the inactive hotend cools down and how much time it needs to heat up, so the slicer can insert the heating command in advance, and the hotend is ready for the change. But there are a few nuances, I'll talk about them in the next video. An important part of the setup is hotend offset calibration. Even though all the hotends are the same, there can be small differences. For everything to work correctly, the printer or the slicer need to know these offsets. Right now the calibration process is fully manual. It's not difficult, but it requires accuracy and about an hour to print the couple of test models. About compatibility. Most likely, if your CoreXY or MakerBot style printer has space in the front to mount the docking profile and the extruder can reach that area, you can install this device with the right brackets. And of course, Clipper firmware is required. The cost of the whole project is actually tiny. I'll prepare a full list of parts for the release. You'll probably see it earlier in my Discord. But in short, besides screws and inserts, the main extruder needs a NEMA 14 motor, a Sherpa gear set, one extra large gear, 2 and 3 pins, one 12mm magnet, one end stop, and a couple of fans. Each tool needs a hotend with the heater and thermistor, a fan, one large magnet, and 4 small magnets. Right now, the project is optimized for the Bamboolab P1P hotend clones. You can probably guess why, because I already had them. They are okay in terms of price and performance. For now, their performance is enough for me, but they are definitely not high-end hotends. I simply don't have the budget right now to get better ones. In theory, since everything is based on the Dragon burner, changing the hotend mount wouldn't be very hard. You just need to remember that the part cooling fan is shared between all hotends, and they should match in height. Each base also needs 4 small magnets and 1 end stops. All of these parts cost almost nothing. The only important thing is having enough wires and 3 ports on your boards. I think that covers the main parts. In the next video I'll explain in more detail how everything works, how to set it up, and we'll run a couple of tests. I can't promise it will come out very soon, I want to prepare it properly, but I'll try not to delay it. About the project overall, this version can be called an early alpha. There are still many small details to polish. Everything needs to be brought to a presentable state. I might run a few beta tests with the people from Discord, and on the then I'll upload everything in a clean final form to printables. The whole project will be open source, so you will be able to improve it and add anything you want. Even though the project is budget-friendly, development itself still requires money. At this point, I no longer have parts laying around in my drawers to keep improving the project. So, right now, I really need your help. If you want to become a part of this project and support its development, the links to a Patreon and regular donations are in the description under the video. As always, thanks to everyone who watched till the end. Leave your comments, hit like, and of course subscribe to the channel and the Discord server to stay updated. That's all for today. See you soon!